Check. That was weird. Computer crashed. It froze. Oh, the camera's not working. Camera. I mean, worst case, we'll continue on without a camera, but it's not that big of a deal. Check. Okay. Come on, you fucking camera. Work. Work, you son of a bitch. You bitch, you motherfucker. Alright, we'll just do theory of mind, what I look like. Here I am. Here I am. Oh, what if I turned it off and turned it back on? Then what? Usually unplugging it and then plugging it back in works, but I'm not gonna do that. Yeah. I don't know. It's not working. That's okay. About another hour to go, so about 3:30. So we'll do this for about another hour. See if we can get through this course.
Default branch. We've been using Git.
Alright, so I was trying to change... I think I changed the branch name. I have it named main right now. To make this repo use main, rename the master branch to main. Run a git branch again to make sure you're on the main branch. I don't know how I did this initially. Expecting main. Bar main. Okay. Submit. Oops. Uh-oh. Did it wrong. Git config global get int default branch. Expecting code 0. Expecting std out of main. Git branch expecting code 0. Expecting std out of main. What was the issue? Expected std out to contain all of main. Oh, what? My std out does say main. Okay, I guess we'll redo the steps. Change your global git configuration to use main as a default branch. Change the init default branch key to main. Change the key. So git config. Add init default branch main. Git branch. Make this repo use main. Rename the master branch to main. Git branch, make sure you're on the main branch. Git config global get init.default branch code 0 command std out contain main. I thought I set the init default branch to main. I did. So I have multiples of configs of the same one. Because I added mine instead of replacing it. So it should be git config remove init.default branch. Can I do equals master? Just remove that one. No. Oh, I have to unset it. That's what it was. So I want to change the Git configuration for init default branch from master to main. Config. So why doesn't git config unset init.default branch? How do I change it? Use the main as a default branch. Yeah, so I did that. Change the init key to main. How did I do that? That was weird. All right. I don't think I was... Change the key to main? I don't think I know how to change key. Git config keys are case sensitive, so default branch and default branch work the same. Git prefers locate. So is it just Git? Key? Git config. Rename section. Remove a section. Remove all matches. Name value pattern. Unset. Remove a variable. That's what I tried to do. Add a new variable. Name value. Is someone just adding? So just git add. Init dot. Oh, this isn't right. Git config add init.default branch key to main. The word main? But now I have the master one too. But I can't remove the first one. So if I want to do like git config remove section init.default branch my god. No fatal, no such selection init.default branch. The fuck? Git config dash remove dash section, then the section.
You should be sitting up straight, but without stiffness, and should feel comfortable. Don't ever let yourself become tense. Now let's type some more on the home row key.
We set init default branch to master at the start of the course.
Using proper rhythm, wiggle your fingers and jam the keys. A quick snap of the finger, and with practice, that's all there is to it. All there is to it. Are you relaxed? You should be, you know.
How do I change git config init.default
Using proper rhythm,
branch to main?
a quick snap of the finger, and with practice, that's all there is to it.
Needs to use git config command with the global flag. Assuming you want this change for all your repositories, is we need
Using proper rhythm, wiggle your fingers
config global init
and with practice,
dot default branch main git config list. So when did we get this global command? Oh. I totally forgot it was a global command. Okay. Remember, this only affects repositories you create. For the current repository, you need to rename the branch separately using git branch m command. Would you like me to explain the next step? Yeah, sure. Git branch. You're currently using a master branch and you want to rename it to main, use this command. Git branch m master main. I did this. Git branch. Change the name from master to main. There's no branch name master. This tells Git to move your branch to the old name master to the new name main. Okay. There we go. Problem was I forgot about the global. Okay, that was a little bit of a clusterfuck, but we got through it.
Visualizing branches. Throughout the rest of this course, we will use text to represent branches and commits. For example, A, B, C main means a branch called main with 3 commits. C is the most recent commit, the tip.
C is just the tip.
B is the previous commit, and A is the commit before that. To represent multiple branches, we'll use multiple lines. D, E, other branch, A, B, C main assignment. Answer the questions based on this diagram. GH lanes branch /, A, C, D primes branch.
Which commits are part of lanes branch ABGH. Which commits are part of the main ABCD? What commits are part of the primes branch AEF?
New branch. You should already be on the main branch, your default branch. You can always check with git branch. 2 ways to create a branch. Git branch my new branch. This creates a new branch called my new branch. The thing is, I rarely use this command because usually I want to create a branch and switch to it immediately. So I use this command instead. Git switch -c my new branch. The switch command allows you to switch branches, and the -c flag tells Git to create a new branch if it doesn't already exist. When you create a new branch, it uses the current commit you are on as the branch base. For example, if you're on your main branch with 3 commits, A, B, and C, and then you run git switch -c my new branch, your new branch will look like this. Branch, diagram, same commits assignment. Create and switch to a new branch called add classics. It should have the same commits as the main branch. Run git branch to verify that you are on the new branch. Run and submit the tests.
We have to create a branch, add classics, and then switch. I mean, we could switch to a git switch C get classics, add classics. Switch to a new branch, add classics. Git branch. Affecting exit code 0. Add classics main. Okey-doke.
Switching branches. We talked about using git switch to change branches. There's another command that you'll certainly run into because it's been around for a long time and older developers are used to it. Git checkout. Git switch is a newer command that is meant to be more intuitive and user-friendly. It's recommended to use git switch over git checkout for simply switching branches. To switch to a branch called prime, git switch prime, or the old way, git checkout prime. For this course, we will stick to git switch, assignment, switch to main, run git branch to make sure it worked. The branch you are on has an asterisk next to it. Switch back to add classics. Run git branch to make sure it worked. Run and submit the CLI tests.
Alright, so git switch main, git branch, then git switch, add classics, git branch, run classics.
Move it, boy.
Up-leveling our abilities. We'll use the add classics branch to add a commit to the project without affecting the main branch. We'll be creating the following branch structure. D add classics -a b c main. The add classics branch will have all the commits from the main branch, plus a new commit. Assignment. Switch to the add classics branch if you're not already on it.
Alright, hold on.
Create.
So git branch, we're on add classics. Create a new file called classics.cv CSV at the root of the project. Yep. Touch classics.csv. Copy and paste the following contents into it. Echo classics.csv. Then concatenate classics. Didn't work. Oh, I have to do echo with an arrow. Into. There we go. Stage and commit the new file. Ugh. Okay, so we gotta add it. Stage and commit the new file. The commit message should start with D in the same format as the previous exercise. So git add classics .csv. Git commit to legit to commit. Alright, M D just call it D. Git log. Sure everything is as you expect. Yep. Run and submit the CLS test instance. And -5 0 0 D git branch 0 add classics. Looks good.
Log flags. As you know, Git log shows you the history of commits in your repo. There are a few flags I like to use from time to time to make the output easier to read. The first is decorate. It can be one of short, the default, full, shows the full ref name, no decoration. Run git log decorate equals full. You should see that instead of just using your branch name, it will show the full ref name. A ref is just a pointer to a commit. All branches are refs, but not all refs are branches. Run git log decorate equals no. You should see that the branch names are no longer shown at all. The second,
Git log decorate full. Okay. Git log decorate no.
is dat1 line. This flag will show you a more compact view of the log. I use this one all the time, it just makes it so much easier to see what's going on. Git log one-line assignment.
Git log one line. Oh my god, that's so much easier.
Run git log with full decoration and the one-line flag. Run and submit the CLI tests. Git files. Kung Fu? No, Gitfu. Remember, Git stores all its information in files in the .git subdirectory at the root of your project, even information about branches. The heads, or tips, of branches are stored in the .git/ref/heads directory. If you cat one of the files in that directory, you should be able to see the commit hash that the branch points to. Assignment. Use find and cat to find the commit hash that your main branch points to. Answer the question.
Alright, remember Git stores all its information in files in the .git subdirectory at the root of your project, even information about branches. The heads, or tips of the branches, are stored in git refs heads directory. If you cat one of the files in that directory, you should be able to see the commit hash the branch points to. Use find and cat to find the commit hash that your main branch points to. So git.git/refs/heads. I mean, go to heads or tips of branches are stored in git refs heads directory if you cat. Ah, nice. What is stored in the gifs refs heads directory? The tips of the heads of the branches. One file for each commit containing the branch that the commit belongs to. One file for each branch containing the commit hash that the branch points to, one directory for each commit containing the branches that the commit belongs to, one directory for each branch. I think it's this one file for each branch.
Branching in Git is practically free, and it really is kind of the core operation when using Git. But at some point, you have to get that work from a branch back into the main line. And this is where merging comes into play. Now, a typical workflow for pretty much every dev looks like this. First, we need to update our repository to the latest code. This is typically done through git fetch or git pull. We'll cover those more later. You branch off the main branch and give it a name that kind of represents what you're working on. New feature A. You fix the bug, create the feature, update the docs, and create your one or more commits on that branch. Then finally, you merge those changes back from your branch into the main line. Typically, when you're at a company, this will involve some sort of pull request on GitHub, on Stash, on GitLab, but conceptually, it's no different than executing git merge on the command line.
Time to merge.
Merge. What's the point of having multiple branches, you might ask? They're most often used to safely make changes without affecting your or your team's primary branch. However, once you're happy with your changes, you'll want to merge them back into the main branch so that they make their way into the final product. Visual. Let's say you're in a state where you have two branches, each with their own unique commits: A muse B, C main, D, E other branch. If you merge other branch into main, Git combines both branches by creating a new commit that has both histories as parents. In the diagram below, F is a merge commit that has C and E as parents. F brings all the changes from D and E back into the main branch. A, B, C, D, E other branch assignment. Switch back to main. Next, our contents.md file is eerily empty. Update it to...
Alright, so we gotta switch to the main. Branch. Git switch. Git switch. Main. Git switch main. Alright, so we're on the main. Next, our contents.md file is eerily empty. Updated to contain contents. Okay. So... echo... the text into contents.md. So one arrow overwrites it all. Double arrow will like append it to the end, right? So that. Then we need, I just want to look at it. So concatenate contents.md. Good. Commit the changes with a message starting with E:. So then we have to git add the file. Git commit. -m. Git commit -m, the file's name again. Oh, and then you got to add the... You're committing the files that you've added. So what do I want to write? E. Ah, shit. That. There. We should now have a commit history that looks like this. A, B, C, D, A, B, C, E. Run git log. One line. Graph. All. And you should see a nice ASCII art representation of your commit history. So A, B, C, E, A, B, C, D. Nice.
We are merging two
Merge commits that are too legit to quit. Alright, hold on. Too legit to quit. Ooh.
branches together with diverging history. Look at this thing right here. The diverging history simply means that main branch, the one we branched off of at point A, has commits, and we, some branch, have added more commits. Main has B and C, our branch, some branch, has D and E. That means when we merge, we need to be able to create a new commit that represents these two diverging histories as one. This is called a merge commit, and it's the only commit with two parents.
I wonder if they need to match, like, B to D, C to E.
The process for a merge commit looks like this. First, we need to find the merge base. The merge base, also called the best common ancestor, is the nearest ancestor that is in common to both branches, and in this case, that would be A. We then play main branch's commits into a new commit, and then we play some branch into that same commit. When all the changes are in that new commit, we commit it to main, and in this case, we call it F, and we give it two parents, one parent pointing to C from the main branch and the other parent pointing to E from some branch. If you use git log, you will actually be able to see the diverging from A, the two diverging commits.
Okay, so this is the main. This is the branch. He has two here and one here, so it doesn't have to be equal.
And then the coming back together in F.
Okay, cool. Cool beans, cool beans, cool beans.
Merge commits. A merge commit is the result of merging two branches together. .git commit. Let's say we start with this. A's BC main DE vim chadsenly, and we merge vim chadsenly into main by running this while on main. Git merge vim chadsenly. The merge will find the merge base commit, or best common ancestor of the two branches. In this case, A. Replays the changes from main, starting from the best common ancestor, into a new commit. Replays the changes from vimchadsunli onto main, starting from the best common ancestor. Records the result as a new commit, in our case, F. F is special because it has two parents, C and E. After A, B, C, F main, D, E vimchadsunli assignment, your current webflex commit history should look like this. A, B, C, E main, D add classics. Merge the changes from the add classics branch into the main branch.
Well, we're on next module. Okay. I'm gonna go to the bathroom before we do the next assignment. So, give me a sec. All right. Get a scone. Your current Webflix commit history should look like this. Yeah, it does. Merge the changes from the add classic branch to the main branch. You'll be presented with a code editor to change the commit message. Update the message to start with F. Aside from that, use a default message. Example, F merge brand add classic. So we're just going to do git merge. Add classics. Okay, so inside this editor, we need to update the message to start with F. Please enter a commit message. Merge branch, add classics. Write out. Save the file, close the editor. From the main branch, yep. Run git log, one line, decorate, graph, parents. So we go from ABC, main is E, branch into D, add classics, then we come back into F. F's parents are D and E.
Logging has to be one of the best tools in the Git belt because Git has extensive logging and observability. If you need to recover work, visually understand how you got to this point, commits along the way, messages that you have created, where the branches and tags are, including in your repository, your remote repository, and of course all the tags that you currently have, and much more, then logging has it. Let's break down a quick command right here. Git log, one line, graph, decorate, parents. Now this looks like a lot of options, but actually it'll make a lot of sense once you understand what those options mean. One line will give you a condensed view of your history. First off, the hashes are shortened to 7 characters, which is the minimum amount Git requires for you to specify a hash. Also, you get the commit message. This gives you a nice quick view so you can see what happened in the past. Graph will draw all the little lines so you can see exactly how your commits have diverged and come back together through merges. Decorate will give you the branch and tag information. This can be nice to see how far you've strayed away from a branch or where a previous branch might be. Parents will give you the parent commit upon every other commit. This can be very nice for merge commits because you can see where the 2 parents came from to create the merge commit. Go ahead, give it a try yourself.
Merge log. Git log. Your output from git log, white one line decorate, graph, parents, aside from the hashes, should look something like
Merge log.
89629A9D234104 B8DFD64 head main. F merge branch add classics. B8DFD64 FBA9 tag 5.8 add classics. D add classics D234104 FBA9 tag 6.1. E update contents FBA 099 1381198 origin master origin main master. C add quotes 1381199A1228F tag 3.7. B add titles.md A212FA add contents.md. Each asterisk represents a commit in the repository. There are multiple commit hashes on each line because the -parents flag logs the parent hashes as well. The first line with these 3 hashes, 89629A9 D234104 BAFD64, is our recent merge commit. The first hash, 89629A9, is the merge commits hash, and the other 2 are the parent commits. The next section is a visual representation of the branch structure. It shows the commits on the add classics branch and the main branch before the merge. Notice that they both share a common parent. The next 2 lines are just normal commits, each pointing to their parent. The last line is the initial commit and therefore has no parent.
The first line with these 3 hashes, so let's say 89 D2 B8 is our recent merge commit. The first hash, 89, is the merge commits hash. The other 2 are the parent commits. D2 and B8. Oh, I can see that. The next section is a visual representation of the branch structure. It shows the commits on the add classics branch and the main branch before the merge. Notice they both share a common parent. They both have FBA 0999. The next 2 lines are just normal commits, each pointing to their parent. Oh, that's cool. The last line's initial commit, therefore, is no parent. It is the parent of parents. All right. Why does the first line show 3 commit hashes? Because it's the first commit? No. Because it's a merge commit, shows its own hash and the hash of both its parents. Can only have 2 parents. No. Wait, can you have more than 1 parent? 2 parents? Merge log.
Logging has to be one of the best tools in the Git belt because Git has extensive logging.
We just did this. Why the weird diagram example? Blah, 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 blah. The graph showing 3 commits were merged into main. So graph showing add classics was merged into main. It's a bug in the code. It's what happens when your brain on Arch Linux after 10 years. It's It's a graph showing add classics was merged into main.
Fast forward merge.
I don't know. Fast forward merge.
Simplest type of merge is a fast forward merge. Let's say we start with this, c delete vscode a mice b main, and we run this while on main, git merge delete vscode. Because delete vscode has score all the commits that main has, git automatically does a fast forward merge. It just moves the pointer of the base branch to the tip of the feature branch. Delete vscode a mice b c main. Notice that with a fast forward merge, no merge commit is created. This is a common workflow when working with Git on a team of developers. Create a branch for a new change, make the change, merge the branch back into main, or whatever branch your team dubs the default branch. Remove the branch, repeat assignment. Because the add classics branch has been merged
Because the adds classics branch has been merged into main, we don't need it anymore. Delete the adds classic branch. Cool. Git branch has done its job. Add, delete, add classics. Delete branch add classics was 50EEF05. Create a new branch off main called update titles. Git switch -c to update titless. Oops. Git switch C update with no space in between titles. Titless. Switch to new branch, update titles. Add a commit to the branch that updates titles MD file and add the curious case of Benjamin Button. Alright, so as a final entry in the list of movies, use G to prefix the commit message. Okay, so we're in update titles. Add a commit to the branch. So do I just echo the curious case of Benjamin Button? Add that to the final entry. So double arrow titles.md and then cat titles md just to see. Alright, I didn't put a dash, but that's okay. Then we need to add git add titles.md git commit -m titles.md. Ooh, but where do we put the... That's right. It's committing all the stuff in the add area. I put the what I want to add here. So this is going to be G. Add Ben. Run git log -- online. Git log? Where's -- oh, one line. I said online. Yeah, so G add Ben is there.
Fast forward commit. Here's a diagram of a fast forward merge. Before, see other branch /a, that's B main. After git merge other branch A is B C main. No merge commit is created. Assignment, switch back to the main branch. Make sure it doesn't have that last G commit with a quick git log. Merge the update titles branch into main. You should see a fast forward merge happen automatically because main doesn't have any commits that aren't already in update titles.
Okay, so git switch main. Make sure it doesn't have that G commit with the quick git log. EF. Yes, no G. Merge the update titles branch into main. Should see a fast forward merge happen automatically because main doesn't have any commits that aren't in update titles. Git merge update titles. Git merge update titles is not a git command. See git help. Oh, git merge update titles. Updating fast forward, one file change, one insertion. Delete the update titles branch. Is it git remove or delete? Git branch D. Git branch delete update titles. Hurrah!
Rebase might just be one of the most misunderstood features of Git. Where the fear typically kind of comes from is that somebody changes the history of a public branch. And when I say public branch, I mean a lot of people rely on this branch for their repos as well. And of course, when they pull and the changes have been somehow altered in the past, all these conflicts and these weird Git errors start happening, and it just causes a disaster for everybody. And then everyone says, Rebase is terrible, I will never use that, only use merge. Well, skill issues. You used it wrong. To understand Rebase, you simply need to understand its primary use case. Rebase helps you to take the diverging commits from one branch and move them to the tip of the base branch that the feature branch is based on. Now that sounds like a mouthful, but it's actually pretty simple. So take this graph right here. We have two branches, main and feature. Feature branches from main at commit A, and main gets B and C added to it, while the feature branch has D and E. Now we want to be able to take the feature branch and get those changes from main. Now with your current knowledge, you would probably merge main into feature, creating a merge commit, and that does have consequences, and we'll discuss more about that in part 2. But for now, let's focus on rebase. Rebase is going to allow you to move forward feature branch from diverging at point A up to diverging off of point C, allowing for a fast forward merge if you wish to get it back into main. This also allows you to maintain a merge commit free history, and again, there are some consequences for that, and they can be quite nice. And that is it. You'll notice this gives you the opportunity to do a fast forward merge and kind of have a free of merge commit history. This will allow for some advanced Git features to be more easily usable if you maintain this type of workflow.
Okay, so rebase just takes the branch, changes the branch base. It rebases it. Hence the name.
Rebase. Rebase versus merge is one of the most hotly debated topics in the Git world. A lot of the discussions you'll see online come down to the fact that many developers, yes, even professionals, don't understand the purpose of rebase and use it incorrectly, causing a bunch of Git havoc, and then blame the rebase command. It's not Git's fault, it's a skill issue. Visualizing rebase. Say we have this commit history, A, B, C main, D, E feature. We're working on feature branch and want to bring in the changes our team added to main, so we're not working with a stale branch. We could merge main into feature branch, but that would create an additional merge commit. Rebase avoids a merge commit by replaying the commits from feature branch on top of main. After a rebase, the history will look like this: A, B, C main, DE feature branch.
Both rebase and merge can be used to integrate changes from one branch to another. True. I have a question for him though. We're working on a feature branch. We want to bring in changes team added to main, so we're not working on a stale branch. We can merge main into a feature branch, but that would create an additional merge commit. Okay, so what is the issue with creating an additional merge commit? The issue with creating an additional merge commit comes down to history, readability, and cleanliness. When you add a merge commit, it can make your Git history more cluttered, especially one on active projects with many branches merging back and forth. This clutter can make it harder to follow the linear progression of your code base. On the other hand, rebase keeps the history linear by replaying commits onto the new base branch, avoiding the extra merge commit. Okay, it just makes it cleaner and easier to read. However, be warned, rebasing rewrites history, which can be dangerous if the branch has already been pushed to a shared repository. Why do you think rewriting history might cause problems in collaborative workflows? People may be working off of different branches at that point. Precisely. If you've already shared your branch with others and working off of it, rewriting the history via rebase changes the commit hashes. This recreates a mismatch between the branch you've rebased and the ones that people are working on. When they try to pull your changes, Git can get quite confused, leading to conflicts and frustration. That's why in collaborative workflows, rebasing is best used on private branches. Those haven't been shared yet. For public shared branches, developers often favor merging to keep everyone's history intact. Okay. Now let me ask, can you explain why Git uses commit hashes to track changes? And why can you explain why Git uses commit hashes to track changes? And why altering history changes these hashes? Now let me ask, can you explain why Git uses commit hashes to track changes? I don't know, it's like a timestamping it? Is it timestamps? Git's commit hashes are actually results of hashing the entire commit object, which includes the contents of the commit, all changes made in the snapshot, the commit message, metadata, author, timestamp, etc. The parent commit the parent commit. So when you rebase the parent commit for a set of commits, you alter the commit history structure. This in turn changes the commit hash because the parent hash is part of the calculation. It's like a chain reaction. Alter one link, a parent commit, and everything downstream shifts. Given this, why might merges not have the same issues of rewriting history as a rebase does? Merge doesn't necessarily rewrite the history. Precisely, a merge respects the existing history in both branches. It doesn't alter any commits. Instead, it changes a new merge commit and ties the two histories together. This keeps the records of what happened and when intact, preserving the original commit hashes. No rewriting means fewer surprises for your collaborators. However, looking at another way, the trade-off of merging is that it often makes the commit history more complex. With multiple branching paths and merging commits sprinkled throughout, the essential records everything, whereas rebase gives a tidier linear sequence of commits at the cost of rewriting. Here's a thought experiment. If your team values a clean linear history, but also requires a public branch, how might you handle both? Is merging, rebasing, or a combination of both a better approach? Merging for the public branch and rebasing for private branch would be best, so a combination is correct. Okay, we're just kind of starting to go into a loop now, but okay. But it's a good reiteration of what's going on. Blank can add additional commit. Blank does not. Merge. Alright guys, I think I'm gonna call it here. Brain's a little cooked. My leg's kind of bothering me too from sitting here. So, have a good evening. I may be working on my Path of Exile 1 through 3 speed running a little bit later, a couple hours. I'll have to think about it. I'm not feeling the greatest, but camera should be up, fixed, and working too. I think my wife's done doing her photo shoot. So, but this is interesting. I'm having fun learning Git too. Looks like we'll be done with it relatively soon-ish. We're about halfway through, so another day, and then we're gonna go back into. I'm gonna build a book bot. Looks like with Python, and then more Python lessons. So. Yeah. So cool. Have a good night. Stay safe out there. Don't do too much dumb shit. If you do dumb shit, do one dumb shit thing at a time. And, so you don't get caught. And I'll see you guys on the next one. Bye.